Hi folks, Mr. Long here. Just going to do some graph sketching with calculus. We worked on this derivative in a previous example. And I think if you remember, we rearranged this to write it as 2x and 2x times by 1/3 to the x. And I think, you know what, I just realized that, like I frequently do, I forgot to multiply that 2 in, so there should be a 2 here. So we ended up getting this derivative right here. 1/3 to the x multiplied by 1 plus ln of 1/3 to the x. And to get our stationary points, or critical points, stationary points, we set y prime equal to 0. Because if y prime equals 0, that means we have a horizontal tangent. So that's where we're going to find our max or mins. We'll do that in a minute. First of all, let's get our intercepts. Okay, so if we look at this equation right here, what's your x-intercept? Well, if you substitute a value, what will make, is there any value of x that will make 2x worth 0? Well, yeah, x equals 0. And so that's going to be 0, 0. And then, because 1/3 to the x, is that ever 0? Think of what the graph of 1/3 to the x looks like. It's asymptotic. It gets closer and closer to 0, but it never touches it. So, no, 1/3 to the x is never 0. Any exponential function, any simple exponential function, b to the x, is never 0. So it doesn't create any x-intercepts. Or if it was in a derivative, it wouldn't create any stationary points. Okay, so what we need to do is look at our end behavior for this. So we've got x and y in a horizontal table here. If I go really far to the left, what's an x value that's really far to the left? Well, we could do negative 100, for example. So let's just zoom in on that a bit. Whoops. So negative 100. So then I'd have 2 multiplied by negative 100 multiplied by 1/3 to the negative 100. Well, what is 1/3 to the negative 100? Think about what that is. That's dividing by 1/3, because that's a negative exponent, 100 times. Well, dividing by 1/3 100 times is the same thing as multiplying by 3 100 times. So what we're actually have got here is 2 times negative 100 is negative 200 multiplied by 3 100 times. Well, that's clearly a huge number, and we know it's negative. So that's approaching negative infinity. Far to the right, at positive 100, say, what would it look like? Well, I'd have 2 multiplied by 100 multiplied by 1/3 100 times. Well, if I multiply 1/3 100 times, if it's 1/3 times 1/3 times 1/3 100 times, well, that's going to be virtually 0. 0 times 200 is still 0. So that gets very close to, I should put an arrow here for approaching 0. So that actually indicates we've got a horizontal asymptote at y equals 0 going to the right. Okay, going to the right. All right, so let's take a look at this then. So I have a good idea of what happens to the left, what happens to the right. I've got the intercept, which is at 0, 0. The last thing I need to do is to get that x-intercept, or to get the critical point and see if it's a max or min. So let's see. If I want to set this equation equal to 0, is 1/3 to the x ever 0? No, it's not, so I don't have to worry about that. Now, this equation right here will be 0. So let's look at it. And, you know, maybe I want to, I can solve for this. Let's see. 1 plus ln of 1/3 equals 1/3 x equals 0. So I would just minus 1 on both sides, right? So I have ln of 1/3 x equals negative 1. And then I'm going to divide by ln of 1/3. So x equals negative 1 divided by ln of 1/3. Now I can rewrite that as x equals negative 1 over ln 1 minus ln of 3. Ln 1 we know is 0. So that ends up equaling negative 1 over negative ln 3, which is 1 over ln 3. So what does that equal? Well, we could use a calculator and figure it out, but I think we know what ln 3 is. It's 1.099. So if we look at that, x is approximately 1 divided by 1.099. And that's going to be our stationary point. So what we want to know is, do we have a min? Do we have a max? Or might we have a saddle point? It's one of those. It's one of those. And, 1 divided by 1.1, that's basically 1 divided by 1.1. So we're somewhere above 0.9. And so what we want to do now is figure out, let's check to the left and to the right. Okay, so let's check to the left and to the right. Now, what we can do is if we go back to the equation, well, let's just do that. So let's just check the slope, the derivative value to the left and to the right. Okay, so we know that f prime equals 2 times 1/3 to the x, 1 plus ln 1/3, like so. Now ln of 1/3, we know is, if I wanted to simplify that a little bit more, that's what f prime is, then I would get 2 times 1/3 to the x, 1 plus ln 1 multiplied by x minus ln 3 multiplied by x. Now we know what ln 1 is worth. That's worth 0. So once again, f prime equals 2 times 1/3 to the x, 1 minus ln 3 times x. So now, remember that we would do like a related polynomial to see. So is there ever any sign change here? Because remember, we're just trying to see if there's a sign change. So is there ever any sign change caused by 2 times 1/3 to the x for any value of x? Well, it doesn't matter if I'm multiplying or dividing 1/3 repeatedly, it'll always be positive, and that 2 is always positive, so there's no sign change there. So the only sign change comes from that. So remember that, and it wouldn't be a polynomial, related polynomial, but I could still call it p prime would equal 1 minus, now what is ln of 3? 1.099x, right? So what does that look like? Well, it's just a straight line. Like so, right? It has a y-intercept of 1. And this value here, we've already figured that out to be 1 divided by 1.099 approximately. Okay, so, and again, this is p prime. So we know that the slope is increasing to the left of 1 divided by 1.099. And that's only approximate, of course. And then it goes downhill because this is negative. Okay, so it's just like our p prime. So that 1 minus ln 3 of x is just y equals, it's just a straight line. B minus mx in this case, instead of b plus mx. Or sorry, instead of mx plus b, it's b plus mx. Okay, so now we know that is a maximum. So what does our curve look like? We know that there's an intercept at 0. We know going far to the left, it approaches negative infinity. We know going to the right that there's a horizontal asymptote at 0. And 1 divided by 1.099, and we know is somewhere around 0.9. Okay, I might get an exact value, but 1 over ln 3. So that's a maximum. So if you look at that, I'm pretty sure that we can draw a curve. It's going to go up like so. It's going to hit a maximum right there. And then it has to come down and like so. And we would know that there is a point of inflection clearly right there. Okay, folks, so that's your sketch. The hardest part of that is that stationary point. And taking that derivative right here and then solving for the stationary point, number one, and number two, then doing the similar thing to a related polynomial to see what it looks like. Okay, what kind of a function is that? And so really it's taking this equation here and being able to graph it, right? 1 plus ln of 1 over 3 times x. And seeing that that's just a straight line because ln of 1/3 is just a number, right? It's just a number. Now, you can, after a while, you'll remember, I think, that 1 plus the ln of 1/3 is always going to be 1 minus ln 3 times x because of your expansion rules, right? So that's going to become ln 1 minus ln 3, and we know that ln 1 is worth 0. So it's just going to become that. And then in time, you will know that ln 3 is about 1.1. So it's going to be something like 1 minus 1.1 x, right? And then that's very easy to know that it's a y-intercept of 1 and it's sloping down. Okay, folks, so again, it's that process there that's really tricky. And again, I just would suggest you set up a table like this when you're graph sketching exponential and log functions. Just look left and right to get the end behavior, get the intercepts, and go from there. All right, have a good night or good day.